When I graph a rational function, I'm going to factor and simplify both polynomials. I'm going to find the zeros, the vertical asymptotes, the horizontal asymptotes, and identify any holes. And then I'm going to use those points to help me plot extra points to sketch in my graph. So I have an x squared plus 3x subtract 4 in my numerator, so I'm going to factor that. And I get x plus 4 and x subtract 1. In my denominator, I have x squared plus 7x plus 12, and I'm going to factor that as well. And I get x plus 4 and x plus 3. So before I go ahead and find zeros, vertical asymptotes, or horizontal asymptotes, I'm going to see if I have any holes. So I have the factor of x plus 4 in common in the numerator and denominator, so I am going to have a hole. So I'm going to set x plus 4 equal to 0, and I'm going to solve. So I'm going to subtract 4 from both sides, and I'm going to end up having a hole at x equal to -4. Now when I go ahead and find my zeros and my vertical asymptotes, I'm going to use only the remaining factors. So for my zeros, I'm just going to have 1, and it's going to be when x minus 1 is going to equal 0. I'm going to add 1 to both sides, and my x is equal to +1. So I have a 0 at +1. And to find my vertical asymptote, I'm going to have x plus 3 equal to 0. I'm going to subtract 3 from both sides, and x is going to be at -3. So I have a vertical asymptote at -3. The last thing I can find is my horizontal asymptote, so I'm going to compare my degrees. Since both degrees for my numerator and denominator are 2, I'm going to create a fraction from the leading coefficients. So the leading coefficient of my numerator is 1, and the leading coefficient of my denominator is 1. So that's going to simplify to give me a horizontal asymptote at y equal to 1. So now I'm going to put all of this onto my graph. So a 0 is going to be a point. So I'm going to put a point on the x-axis at +1. My asymptote lines are dashed, either vertical or horizontal lines. So for vertical, it'll run up and down, and for horizontal, it's going to run left and right. So I'm going to have a dashed vertical line through x equal to -3. The reason we dash these lines is because they are not actually part of our graph. We just consider them to be boundary lines. And I'm also going to sketch in a horizontal dashed line at y equal to 1. I'm going to save my hole for when I plot points. So now I have a general idea of what my graph could look like. So I'm going to go to my calculator and put the original equation in, and I'm going to use parentheses to block off the numerator from the denominator. So I've put my rational function in the calculator, and you can see I have my numerator in parentheses, my division in between, and then my denominator in parentheses. So I can hit enter, and this gives me an idea of what my graph is going to look like. I don't see either one of my asymptote lines, but I do see what those boundary lines are doing to my graph. So I'm going to go into my table, and I'm going to work left to right. So I have a left portion of my graph, so that's going to be all on the left side of that vertical asymptote line. So I'm going to look from -3 to -10, and I'm going to plot as many points as I possibly can. Now with these rational functions, a lot of the points are going to be decimals, and a lot of them could be close together. So we want to try and plot as many as possible, preferably 2 or 3, but if we can only get 1, then we can only get 1 point. So So I'm going to scroll up in my table to my -3, and I see that it's undefined. I also see at -4 that it is undefined. That's where I have a hole. So I'm going to come back to that in a minute. So I'm going to look at -5, and it has a y coordinate of 3. So I'm going to plot that point on my graph. Then I'm going to scroll up a little more, and I can see at -7 I have another good point at +2. And then here at -10, it's at 1.57143, which is pretty much 1.5. So I'm going to plot that at -10 and 1.5. So this gives me an idea of what my graph is doing. So now my hole. My graph is actually not going to exist at that x coordinate of -4. So I'm going to sketch in an open circle on the -4 axis line, somewhere where I think the graph would trend. So if I would sketch this in, I see that my graph hugs both of those asymptote lines. So where I would approximately have my x equal to -4 coordinate point, I'm going to plot an open dot. Now for the right side of my graph, I'm going to do something very similar. So I'm going to go back to my asymptote line that was at -3, and this time I'm going to go from -3 all the way to a +10. That way I am on the right side of my vertical asymptote line, creating that hyperbola on the right side of my graph. So I'm going to scroll back down in my table to a -3, but this time I'm going to go towards my positive numbers, and I'm going to plot as many points as possible. So if I look at -2, I have a point at -3. At -1, I have a point at -1. We have our +1, 0, because that was our 0 that we found in our problem. And if I keep scrolling, our decimals slowly get bigger. Here at 5, I have 0.5. And that's probably going to be about the last good point that I have. So I'm going to connect these 4 points, and I'm going to stay to the right of my vertical asymptote and below my horizontal asymptote. So these rational functions, we don't always have perfect exact points. We're not going to have every point from -10 to +10. We are going to graph what we can, make sure we plot our holes. We're going to estimate where they would go in the graph, and sketch in our curves, and we're going to make them look like the graph that we see on our calculator screen.